The universe travels the path of entropy. The only way forward is chaos.
This is the future.
What is up, YouTube? And welcome to the first episode of my Phenom setup series. This is going to be a short little video series where I go through the journey of setting up my own resin printer, doing it sort of my own way, but following the tried and true methods that have been laid down by so many others out there. And I'm going to share my whole process. I'm going to be going all out on this. I have invested a lot of money into this printer, and I've invested a lot of my time and energy into what I need this printer for, and the things that I want to do with it. So I need to make sure that it's going to work the way and I need it to work. It needs to work reliably, and that means making sure you get everything done just right. So in this first video, I'm going to go over getting the printer set up. Now, one of the upgrades that I've purchased for my Phenom is a Wham Bam system. This is a magnetic plate that sticks to the bottom of the build plate, which means that you don't have to take the whole build plate out to get your part out to do the scrapey, destroy your build plate of doom. Instead, there's a magnetic plate that is stuck to the build plate. Then you have these steel sheets that stick to the magnet. And when you want to remove the part when it's finished, there's a tab that you grab hold of, pull down, and the whole thing comes loose. And it's brilliant. It makes life so much easier for resin printing, especially for these large-scale resin printers. So I ordered the double Wham Bam system, which means as soon as I'm done printing one, I can pull that plate out, put the fresh one in, add some resin, and hit go. And I can just print continuously. So this video, we're going to look at getting that set up. The steps that you have to take to make sure that you get a good adhesion of the magnetic plate to your build plate, and to go through the steps of setting the Phenom up become a little bit different because you've changed the thickness of the build plate surface, and that means your homing sensor is not going to work. So I'm going to go over how you have to change your homing sensor and the steps you need to go through in order to do that properly. So let's get into it. Right, first things first, read the instructions. This is important with anything that you do. Always read the instructions, make sure you know exactly what it is you're doing, even if you think you know what you're doing. Read the instructions. The kit comes with two different sandpapers, 400 and a 220. Start with the 220, which is the deeper grit. This gives you deeper scratches, bigger, like it just removes more material. Go with this one, go in all directions, circles, diagonal, straight lines, and 90 degree and 0 degree. As you can see here, this gives you really good cut in all kinds of directions for the adhesion to work and stick. Next up, wash it all up. Make sure you clean that thing thoroughly. I washed it a good 2 or 3 times off camera, just to make sure that I've gotten rid of any of the grit particles that might have been come off the sanding paper, or any of the aluminum grit that's been scraped off by the sandpaper. And then clean your workstation, clean where you were sanding, clean everything, clean thoroughly. You do not want any loose particles of grit getting into the next stage where you're using the finer sandpaper. So clean everything properly, use multiple wipes and stuff so that you're not carrying over any of those particles over to the next stage. And then you just thoroughly wipe down the build plate, make sure it's nice and clean, let it dry, let it sit and dry. And then when you come back, you grab the next piece of sandpaper and you do the same thing again. But this time you go a little bit lighter. So the idea here is, now you started by creating lots of scratches, deep scratches in lots of directions. Now you come in with this lighter sandpaper and you create additional slightly shallower scratches alongside with all those deep ones. You're not trying to remove the original deep scratches with this, so don't sand too heavily with this. And this gives you different kinds of deep scratches and light scratches all over. Then again, wash it off again. I've washed it off camera, same as previously, multiple times. And then after you wipe it down, you get some, you can use IPA. I have the wax and grease remover on hand because my IPA hadn't arrived in the mail yet, so I didn't have any alcohol to clean this down with properly, so I use wax and grease remover. So going through, same again, multiple stages, using multiple wipes. As you can see there in that first stage, there was some residue, some grit left over on the wipe. So then I fold the wipe over so that it gets trapped inside, and then I can use the clean side of the wipe to do the next wipe. So wipe it multiple times, make sure it's thoroughly clean. You don't want any particles remaining on the surface there. You can see there's still some dirt, some marks, and some grey particles there. So folding the cloth, going back in, wiping it again, making sure you're getting it really nice and clean. I wipe this thing so many times. The cleaner you get this surface, the better the adhesion, the longer this kit will last you, the longer this Wham Bam will stay on that build plate. And it's so important that you just take your time with this to get a good result. So there, cleaning up after myself. Now I'm going to use these alcohol prep swabs that my mum can bring home from work. She works in the hospital, so I get loads of these. So I can use this to clean the surface off, since my IPA, my alcohol, hasn't arrived in the mail yet. So this is the only alcohol I've got access to wipe the surface. And then carefully peeling half of the covering off the Wham Bam plate, the magnetic sticker. And then you just line up the one edge and the corners on one side, like just the very edge. The adhesive coating on this thing is very sticky. So you just carefully line up the very one edge and the corners, and then it should just fall straight onto the plate with no issues. You should. I've had lots of practice doing this kind of thing, putting decals and stickers on surfaces on cars and motorbikes and stuff in the past. So this wasn't too difficult for me. A lot of people will have issue with it. So that's the trick I can give you, is to make sure you line up at least one edge in the corners, and then the rest will just fall in place. And there it is, put on and everything. So just testing out the steel plate here, and this magnet is so strong, eh? It's just snapped on there. Like you get one side lined up and then bang, it's on there. Peels off nicely. Oh, I cannot wait. This is gonna be so good. And then here you can see I'm just checking to make sure that all my edges are nice and clean and lined up. No overhangs, no undercuts. And there it is, Wham Bam. Thank you, ma'am. And there you have it. That's step one done. Wham Bam installed. Now, next step. This one's a little trickier. This is the bed leveling step. Now, in the Phenom instructions from Peopoly, they suggest that you level the bed using a sheet of paper against the LCD screen without the VAT installed. There is this thing called the Flint Read method, where you actually level it inside the bed against your FEP sheet, and this gives you a level compared to your FEP sheet. People see a lot more success using this method than using the manufacturing method of using the piece of paper underneath. So yeah, we're going to be using the Flint Read method. There's a link in the description if you want to check out his original video on that. But basically that's what it is. You do your bed leveling the same as you do with the sheet of paper, but instead you do it in the bath with the FEP sheet. But like I mentioned, because we put this Wham Bam plate on, the distance between the bottom of the build plate and where the FEP sheet is, there's now a gap because of the Wham Bam system in the way there. This distance is so great that the optical interrupt sensor that is on the vertical carriage that detects when the build plate reaches its home position no longer reaches the optical gate, which means you now have to loosen the screws that hold the little spade that comes and breaks the interrupt, so that you can shift it down a little bit so that it does break the interrupt. So we're going to go over those steps in this next segment. It's pretty simple. So let's get into it. Now getting started, just pulling off the Glad wrap off of this. You got to be careful doing this. Try and hold it from the top edges of the vat, and don't put any pressure on that FEP sheet. You don't want to bow it or bend it too much. Just be very gentle with it. I'm just here making sure that there's no dust or particles sitting on it, that when I slide it in there, it could scratch up the surface or tear it, or anything bad. Just with anything with resin 3D printing, you just want to be clean. Everything needs to just be clean, no dust, particles or anything. The more clean you keep it, the better your results are going to be. So yeah, just putting the screws in for the vat. Plug her in. Turn her on. Take your bed out. Loosen up the leveling screws. So this is different for different 3D printers, but this is basically the setup for the Phenom. You got these 4 screws around this carriage, and they've got some slots in there so they move up and down. put your Wham Bam sheet on. This is important because you need to get the exact tolerance of the sheet on the build plate, and without that sheet there's a difference in thickness and your homing sensor won't be set up right. Now when I was cleaning this I noticed that these sheets, these Wham Bam sheets are very filthy, like seriously filthy. This is, I think, a byproduct of the way they're manufactured using the laser cutting. So when these sheets get cut out of the sheet with the laser, there's a lot of the smoke and the particulates from that cutting process gets left on the surface. So just make sure you clean your Wham Bam sheets properly before you use them. Go into manual and bring the build plate down. Get it as close as possible. Don't run it into your bed. Please be careful. Get it there and just make sure that you've got your travel on your carriage for your build plate at about the midpoint. And then you'll notice here that that spade isn't interrupting that optical sensor. So this is your Z sensor for the printer. Now you just want to go in and loosen these two screws so that the spade, there's a little bit of a play in the holes for the screw, you can see there. So you just want to loosen it so that it can move around. Make sure it's pushed all the way down to the bottom. Check you've got plenty of travel on your bed so that when it comes down further, it's not going to crash the lead screw. Line it all up. Hit home. And then it will come and find a nice happy position where that spade is interrupting the sensor. Now you see that the light came back on when I tightened it up, so the spade's moved again. But this just means that I can't, the first check is to make sure I do have clearance to do it, then you do it again. And now it will find the position with where the spade is now. And there you go, it stays light, the light stays off. And this is where you come in and you tighten the screws on your build plate. Don't go too crazy, just make sure they're tight enough to stay still. And nothing's going to shift or move. And then hit home one more time just to check. So now it was already in the home position, so it's just going to go up and down. So then move it up and hit home again. And now it will come and it'll do its homing check. And then come down slowly and stay in the home position. And there you go, and that's it. Done. Nice and easy. And it's as simple as that. So, hopefully this was helpful to some of you, and hopefully you enjoyed the video. We're going to leave this one off here, and we'll come back in another episode where I will discuss setting up the resin printing itself. Like I said, I'm waiting for stuff to arrive in the mail, so when that episode arrives is dependent on shipping times. But I'd like to talk about a couple of the other things I have planned for this printer. So, one of the quirks with using Tech blue resin is it prefers to be printed at a slightly warmer temperature, which means having some way to heat up the cabinet inside of the printer would be, helpful. Peopoly does offer a heating element for their Moai, which is their old resin printer design. I wanted to try something different. So what I've done is I've ordered a PID temperature control unit with a temperature sensor, and I've also ordered a thermal heater. It's a small little fan with a Peltier heater on it, and that's just going to fit inside the enclosure. So that, among a couple of other things that I have planned to mod the usability of my printer to improve its performance, basically. You can get away with printing a lot of these resins and that without needing to heat your environment, but I find that having that temperature controlled environment is going to give me more repeatable results with my resins. And especially when I'm planning on mixing the resins in different ratios to do tests on their different material properties when they're mixed in different ratios. So we can get a definitive answer of, for example, if you use 50% of their fast resin and then you add in 30% blue and 20% tenacious, is that going to change the material properties in a certain way? Or if you use equal parts of all, or if you only use 10% of blue and 10% of tenacious and the rest of it's fast, what does that do? So I want some numbers on that, and so I can make better choices about what ratios of resins to use to tailor the material properties for whatever it is I'm printing. I plan on printing a lot of engineered parts that are require to be a moving parts that are required to take impacts, parts that are just structural. So I need to be able to tailor my material properties for those engineering requirements. To do that, I need a repeatable environment to print with. So that's why I'm planning on using a heating system to maintain the temperature inside of the cabinet. Some other modifications that I've already done is a lighting system. I noticed that when I'm working inside of the cabinet, it gets a bit gloomy. It's a bit dark inside there. So I installed these two nice light strips on the ceiling. In the future, this wiring will also include the wiring for the thermal control unit that goes to a little control box that I plan on designing and printing and putting on top of the printer. This will have my switches for the lights and everything, and it'll look a bit more professional. When the printer is in operation, these lights will be turned off because I don't know how these lights will affect the kickoff of the resin as it's being printed. So better safe than sorry, just turn it off. When I need to then access the printer before or after a print, I can turn it on, get in there, do what I need to do, close it up, turn it off. Not a problem. Hopefully you enjoyed the video. Make sure you hit the like button, subscribe if you haven't already. There's a Patreon link down below if you want to check that out. That would be awesome. So I've been Chaos, and as always, expect the unexpected, and I'll see you guys next time. And a special thank you to all my patrons that help support the channel. If you would also like to support the channel, there's a link in the description.